Hi students, welcome back to Physics for All YouTube channel. In this session, I am going to explain about Newton's rings experiment. In order to form Newton's rings, we have to maintain two glass plates, plano-convex lens, travelling microscope and monochromatic light as shown in this diagram. And it is a laboratory setup of Newton's ring experiment. Now in this first diagram, we have to arrange this plano-convex lens on the plane glass plate and take another plane glass plate which is arranged at 45 degrees in front of this glass plate. We have to maintain monochromatic light source. The example for this monochromatic light source is sodium vapor lamp, and it is a travelling microscope used to see the Newton's rings. Then we will discuss how these rings are going to form in detail. Now, when source is on, light rays are coming from the sodium vapor lamp. These light rays are incident on the glass plate, then light rays are reflected towards the plano-convex lens and get refracted into the lens. Now these refracted light rays again enters into the air film present between the lens and the glass plate. Then what happens we can discuss by using this diagram. Now this is a light ray coming from the air medium incident on the lens. This light ray is refracted into the lens and again refracted into the air film. Now this light ray splits into two parts. Some part of the light ray get reflected from the upper surface of the air film in the path of 2, and other portion of the light ray refracted into the air film and again reflected back from the lower surface of the gap and again comes from the form of ray 1. So finally we are going to get two light rays. This is the first light ray getting from the reflection on the lower surface and other light ray reflection from the upper surface. Now these two rays are going to superimpose with each other depending on their path difference. Therefore, now we have to calculate path difference between the ray 1 and ray 2. Now the equation for the path difference already we derived in the interference in thin film reflection. Delta is equal to 2 mu t cos r plus lambda by 2. Now here light rays are coming from the air medium, therefore refractive index of the air is equal to 1. Substitute in the above equation, path difference delta is equal to 2t cos r plus lambda by 2. Here mu becomes 1, therefore the place of mu we are writing here 1, therefore delta is equal to 2t cos r plus lambda by 2. In the case of normal incident rays, r is equal to 0. Then delta is equal to 2t into cos 0 plus lambda by 2. Then path difference delta is equal to 2t plus lambda by 2. Now at the point of contact, now this is called point of contact. There is no air gap between the lens and the glass plate. Therefore there is no air film. Hence we have substitute t is equal to 0 in the above equation. We are going to get delta is equal to lambda by 2. Therefore, at the point of contact, path difference is equal to lambda by 2. That means at the point of contact, the two reflected light rays meet at out of phase. Because of this reason, the two rays interfere destructively and produce dark region at the center. Because of this reason, at the center of the Newton's rings, we will observe dark region. This is the reason. This topic is important for the short answer question. Now we have to derive condition for the brighting. Now take this equation, that is delta is equal to 2t plus lambda by 2. So to get bright ring, it is equal to the integral multiple of lambda. Already we discussed in the interference in thin film by reflection. So from that 2t plus lambda by 2 is equal to n lambda, where n is equal to 1, 2, 3, 4 and so on. In this equation, send lambda by 2 to right hand side and take LCM. We are going to get 2t is equal to 2n minus 1 into lambda by 2, where n is equal to 1, 2, 3, 4 and so on. It is the equation number 1. And similarly we have to get equation for the dark ring, that is 2t plus lambda by 2 is equal to half integral multiple of lambda. It can be written as 2n plus 1 into lambda by 2, where n is equal to 0, 1, 2, 3, 4 and so on. Now in this equation, send lambda by 2 to right hand side and take lambda by 2 as common factor, and we can cancel plus 1 and minus 1, and finally we are going to get 2t is equal to n lambda, where n is equal to 0, 1, 2, 3, 4 and so on. Now equation 1 and equation 2 are the conditions for the bright ring and dark ring in the case of Newton